Now coming to the last component of the system programming, that is nothing but a compiler. Now what do you mean by a compiler? A compiler is nothing but a computer program that is going to translate a computer code written in any one of the programming languages, which we call it as the source language, into another language that is called as a target language. The name compiler is primarily used for programs that translate the source program from a high level language to a lower level language. So that is called as an object program, or we also call it as a machine program, in order to create an executable program. So here it is a program which is going to accept the source program in any one of the languages such as C, C++, Pascal and so on, and translates it into the respective machine language which is being termed in terms of zeros and ones. So the basic task of a compiler is to perform all the above. So if you observe in the diagram, we have the source code. Source code is nothing but any of the high level languages which is being considered as the input to the compiler, and this compiler is going to convert the source program into an object code or an object program which is called as a machine. Now coming to the example of any programming language, we have WCM, that is the procedure, wait, start, finish, declare. So we are going to declare cost, rate, start, finish, and then we consider the fixed binary which is of 31-bit size, which is static, and then the cost is calculated, that is rate into start minus finish plus 2 into rate into start minus finish minus 100. So we are going to return the cost. Now what exactly the compiler will do in order to produce the machine language equivalent of the above program? So here first of all it has to recognize the strings as basic elements, that is it will recognize the cost which is considered as a variable, and then WC is nothing but a label or a symbol, and we have a procedure. Procedure is nothing but a keyword, and equal to is considered as an operator. So these strings are going to be considered as a basic element. And then coming to the next one, it recognizes the combination of elements as syntactic units, and then it is going to interpret their meaning. That means it ascertains that the first statement is nothing but a procedure name with 3 arguments, and the next statement is considered to be defining 4 variables, which is to be of fixed binary number of 32 bits. And then the third statement is nothing but an assignment statement which requires 7 computations, and that's considered as the last statement, which is going to return with 1 argument. And then it allocates the space in the memory and assigns certain locations for all the variables in the above program. And lastly, it is going to generate the object. Now coming to the phases of the compiler, as you see in the diagram, we have the high level language. So this high level language is being sent to the lexical analysis phase. So this lexical analysis phase, it is going to take the program and then read it and finally converts it into tokens, that is called as stream of tokens, and then it is being given to the syntax analysis phase. So this syntax analysis phase is also called as a parser, which is going to accept tokens and convert it into parse tree. And then this parse tree is being sent to the semantic analysis phase. So this semantic analysis phase accepts or reads the parse tree, which will be given to the semantics analysis, and then this again verifies the parse tree whether it is meaningful or not. That means it is called as semantically parse tree verified. Now this parse tree is being sent or accepted by the intermediate code generation, and this intermediate code generation is going to generate three address code, but there are basically many address codes, but among this the three address code is very popular. So the out of the intermediate code generator is given to the code optimization. So the main purpose of the code optimizer or the generator is to reduce the size of the program or also reduce the number of lines, and thereby it will be giving the target code generator. So this target code generator will finally generate the assembly code. So during all these phases, or the entire module of the software will take the support from a table which we call it as a single table manager. Moreover, all of them will be dealing with a module called. Now coming to the source program, that is nothing but an example. Here we have x is equal to a plus b into c. So this source program is given to the lexical analyzer. So this lexical analyzer accepts the input and it is going to be converted into the tokens. So the other purpose of the lexical analyzer is they remove white spaces before or after the expression whatever we are going to have, or else the comments which are going to occur are removed through the lexical analysis or the lexical analyzer. So this identifier, that is id is equal to a plus b into c. So we write the expression as id is equal to, you can write it as either id1, id2 and id3, or you can just specify it as id plus id into id. So these identifiers are nothing but the regular expressions which are being used as patterns. So what it will do is, this syntax analyzer is going to identify the patterns, or it matches with the patterns and is being specified as identifiers. So that is nothing but, we have the expression that is the syntax analyzer. So what it will do is, it is going to accept all the tokens one by one and also the grammar, and it makes uses of the rules of the languages or the rules and regulations of the languages, which is nothing but the production. So if you observe in the statement here, we have S, that is nothing but the statement which is going to derive an identifier and expression, and this identifier derives your expression. So we have the expression. This expression can be specified as expression plus term or term, and then we have the term which is being specified as the term or a factor, and finally we have a factor which is going to specify it as an expression or simply an identifier. Now if you look into the program, the expression here, diagram, we have the statement. So this statement is going to derive the identifier, that is nothing but equal to an expression. So this expression derives your expression plus the term, and this expression again derives your term, and the term derives your expression, factor, and then finally the factor is going to derive your identifier. So similarly, the term is going to derive your term and then into the factor. So here the term in turn again derives the factor, and then the factor is going to finally derive the identifier. So if you observe here, we are going to match the pattern of with the expression whatever we are going to have. So this is being specified, the rules which are being used using your syntax analyzer. Now coming to the the syntax analyzer is also called as your parse tree. So this parse tree is being specified to the semantic analyzer. So what does the semantic analyzer will do? It is going to check for the parse tree verification, which is nothing but semantically. Now what do you mean by semantically? Semantically is nothing but meaningful information, whether it is meaningful or not. That is, it is going to check whether the left hand side is equal to the right hand side, or it is compatible with the left hand is compatible with the right hand. So this semantically verified parse tree will be given to the intermediate code generator. So this intermediate code generator generates the intermediate code. Basically, there are three address code, that is which is shown here as T1 is equal to B into C, T2 equal to A plus T1, and X is equal to T2. So the given statement is being specified as 4 address code, whereas this is being reduced to 3 address code with the help of the intermediate code generator. Now why exactly we have to convert into the intermediate code generator? That is nothing but if we can convert it into the intermediate code, then that particular intermediate code can be converted into the machine language using the last two phases. That is nothing but your code optimization as well as the target code generator. So these last two phases, which are dependent on the platform, will specify what exactly or how exactly the assembly language will be specified. Now in this case, if we have to redesign a compiler, there is no necessity for us to change from the first phase till the intermediate code generator. Only the last two phases can be changed depending upon the machine or the assembler which we are going to use. So now coming to the code optimization. So this code optimization or the optimizer is going to reduce the number of lines of code. Here we are going to have only 2 lines of code, that is from 3 we are going to reduce it to 2 lines of code. So the output of this code optimization is given to the target code generator. Now what is the main purpose of this code optimization? So the code optimization is to write the code in which the assembler can understand. Now depending upon the type of assembler, we need to have a code optimizer. Now if you see theoretically, all these things can be done, but if you're going to do it practically, then we don't require all the phases, but most of the functions are being done by the syntax analyzer. So the last target code generator is going to generate the code that is nothing but the example. If you have here, we have three codes. One is nothing but multiplication, which is being specified as R1 comma R2, and then add equal to R0 comma R2, and then move equal to R2 comma X. So this is nothing but the complete phases of the compiler. Now the lexical analyzer, syntax analyzer, semantic as well as the intermediate code generator will come under your analysis phase, whereas the code optimization and the target code generator comes under your synthesis phase. So similarly, if we have the four phases, the first four phases, we call it as the front end, and then the code optimization as well as the target code generator are considered as the back. Now whatever you have seen in the previous diagram, the same thing is represented into two phases. One is called as the analysis phase, the other one is termed as the synthesis phase. So in the analysis phase, we have an intermediate representation which is being created from the given source code. So under this, we have four phases. One is called as the lexical analyzer. The second one is termed as the syntax analyzer. The third is the semantic analyzer. And then we have the intermediate code generator. Now similarly, with respect to the synthesis phase, so this synthesis phase is going to represent a target program which is being created from the intermediate representation or the intermediate phase. So it has two parts. One is called as the code optimizer, the other one is termed as